Hey everyone, today we're on Unit 12, Lesson 4, and we're going to be talking about when to use the chain rule. In our do now, we want to find f prime of x. If f of x equals 3x to the fourth, this is a simple f prime of x is going to equal 4 times 3, 12x cubed. Okay, nice and easy. However, if we look at example 2, I have f of x equals 3x in parentheses raised to the fourth power. This one is not so simple. We have to rewrite this first. 3x to the fourth is really this. Or in other words, 3 to the fourth times x to the fourth. So this would be 81x to the fourth power. And now when we go to take the derivative of this function, f prime of x is going to equal, 81 times 4, 324, x cubed. Okay, so notice the difference in the derivatives of each of these, and notice the difference in how you would evaluate. In the first example, if I asked you to plug in, let's say 2, you would do 2 to the fourth and then multiply it by 3. If I asked you to find 2 here, you're multiplying it by 3 first and then raising that to the fourth power. Okay. When we're doing that, this is called a composition of functions. And whenever we need to differentiate a composition of functions, we use the chain rule. So for the chain rule, if your original function is a composition, f of g of x, then the derivative is f prime of g of x times g prime of x. Okay. This is a little difficult to recognize at first, and I know the notation is hard. So when I do the chain rule, this is when the words help me the most. It's the derivative of the outside function times the derivative of the inside function. And the easiest way to know when to use the chain rule is when you have a set of parentheses being raised to a power. Because I know you guys are not math teachers, so it's not that easy for you to understand when something is a composition, but it is easy for you to see when I have a set of parentheses being raised to a power, I'm going to do the chain rule. The derivative of the outside times the derivative of the inside. So I'm just going to kind of, in a different color, go back up here to this guy. If f of x equals 3x to the fourth, then f prime of x is going to be the derivative of the outside. So I'm going to take the derivative of the set of parentheses. Leave what's inside alone. Now take the derivative of the inside times 3. So I have f prime of x is going to equal 4 times 3 cubed is 27 times 3 times x cubed. And you would wind up getting the same answer. Now, I know it doesn't seem easier to do it this way, but it is. Okay, because a lot of times we're not going to be cleaning up that inside. We're just going to be leaving it alone. So let's just kind of jump right in here. Set of parentheses being raised to a power. Right? 2x squared plus 7 cubed. I could FOIL it all out and do it that way, or I could apply the chain rule. F prime of x is going to equal derivative of the outside function. So we're going to leave that set of parentheses alone. And we're just going to differentiate that outside function. And now go inside and take the derivative of the inside. And now all we're going to clean up, we're going to leave the parentheses alone. And you're just going to worry about anything that's kind of hanging out. And there you go. Just like every other rule we learn, we have to kind of always remember, does not apply to a square root sign. So before we begin, we'd have to rewrite this. This is 1 minus t to the 1/2 power. Derivative of the outside. 1/2. Leave what's in parentheses alone to the negative 1/2. Take the derivative of the inside. Now I'm looking at that. -1. And now we're just going to clean up what we can. But I'm losing Wi-Fi. I'm going to pause this and move to a better place. Okay, hopefully I'll stay connected here. So now, again, we're going to kind of clean up. We're going to multiply anything that we can together, simplify if you can, and we're going to rewrite this in the denominator back in a radical sign. 2 times the square root of 1 minus t. Okay, so what you guys have to remember is how important it is to remember our old algebra skills. We can't forget them. Let's look at example 3. In example 3, rewrite. So we have this entire, what's underneath your radical sign, and we're raising that to the first power. So this is going to become 1/3. Derivative of the outside. Leave the inside alone. Times the derivative of the inside, 18x. Now, just kind of reminding you, these are all fractions now. Those are over 1. This is in my numerator. This is my denominator. So I can clean up and simplify things. Y prime equals 6x over, this is the cubed root of 9x squared plus 4 squared. In example 4, when we look at this, we see we have 2 factors. You may want to jump to the product rule. So let's try it and see what happens. Actually, let's not, because what do I notice about that number out front? This is just a multiplier. There's no variable attached to it. Okay, so we can just treat it like a multiplier. So we're going to take the derivative of the outside, just like it's very similar to the power rule we first learned. Subtract 1. Now take the derivative of the inside, and that's -9. So I get, cleaning this guy up, g prime of x is going to equal -108 times 4 minus 9x cubed. So that really wasn't so bad. Now, when we look at number 5, what do you notice different about this? If I go out front here, that has an x now. So these are actually, I have to use the product rule. Okay. I have 2 functions. Now, your only other option would be to raise 4 minus 9x to the 4th power, which is just not going to be good or easy. So whenever I have this situation, I usually break this down and I rewrite it and I think about a u and a v. The u is my first function and the v is my second function. And I know g prime of x, if I want to write it with u's and v's first, is the first times the derivative of the second plus the second times the derivative of the first. Now what you could do on the side is, if u equals 3x, u prime is just 3. If v equals 4 minus 9x to the fourth, v prime is equal to 4 times 4 minus 9x cubed times negative 9. All right, so this problem is, a pretty complicated problem. Follow along the best you can, because now we're going to take our g prime of x and we're just going to substitute. U is 3x. V prime is negative 36. 4 minus 9x cubed. Right, first times the derivative of the second, plus the second function, 4 minus 9x to the fourth, times the derivative of the first, u prime, which is just 3. Okay, now what we have to do with this is we've got to clean this whole thing up. So 3, I'm going to have negative 108x times 4 minus 9x cubed plus 3 times 4 minus 9x to the fourth. Technically, you're done, but sometimes in your calc class, you're going to have to kind of factor this further. So we're just going to review that right now, nice and simple. If you recall from earlier in the year, we talked about kind of factoring expressions like this. This first term has 2 factors, and this second term has 2 factors. So we're going to look at the GCF from the first term, and at 108 and 3, I'm going to just factor out I'm going to factor out the negative as well. So this would be negative 36. And that's the only things they have in common. Now we look at the second term. And in the second factor, they each have 4 minus 9x cubed in common. So you factor that out. And now you set up your big set of parentheses and you just do what's left. So if I took and I factored negative 36 out of negative 108x, I'm left with 3x. All of that came out. This is going to change to a minus sign. And I have 4 minus 9x to the first power. Now we can clean up what's in here. 3x minus 4 plus 9x. And we're left with 12x minus 4. And I would just leave that alone from there. And again, this was a tricky one. I don't think I would give something like this on a test at this point. I just kind of wanted for you guys to see the difference of what to do when it's just a straight coefficient in front and when you have something that has a variable in front. Okay. Let's just try one more before we end. In this example, nice and easy, all we have to remember to do is bring this radical sign up top and rewrite it with a negative power before we begin. I have something being raised to a power, so I'm going to use the chain rule. -1/2 times 2 is -1, right? Derivative of the outside. Subtract 1 to get your new power, times the derivative of the inside, plain old 6x, rewrite it. When I move this expression down, 3x squared plus 5, it's the square root of this cubed. And that's your answer. Okay, so I'm going to give you a little bit of time to complete some of the practice problems, and we will see you again tomorrow.